Okay, great. So let's start. Actually, I'm curious. Has anybody seen the last workshop that I did for TDSW about L-system? Maybe you could say yes or no on the chat. This is not necessary to see the last workshop, but it definitely helps. And you don't have to worry if you didn't see it. But last time I did really deep into this L system itself. And we, kind of covered a lot of different rules, which is, if you open the example file that we sent you today, there are some rules right here. So I don't go to too much detail in this part today, but rather try to, complete this whole scene. And yeah, so the L system portion will be a little bit smaller today, but it'll be, in a way, it's more fun because we have a lot of more fun parts to work on. So that's kind of how it's going to be today. Feel free to ask me any questions as we go. I will try to answer. And I think it's not a bigger group compared to last time. So, feel free to let us know if you stuck anywhere during this workshop. So yeah, first, if you open this example file, there's this text for the sort of snippets for the rules, and then there's an instruction of how to use it. So this Autometry workshop component, first of all, if you are using Mac, and by chance, if this view looks too blurry, that could be because if you go inside, there is these two Luma blurs. If you are using Mac and if you're experiencing the weird blurriness, please just bypass this one. Okay, so that should fix the blurriness. We noticed that yesterday with testing. But with that being said, so if you make view active, and then if you click inside of this component, basically you click like a tree or the leaf, it will change this color. So, and then along, changing the color, also the particle will be emitted, and then it will land on this water surface. So that's what we are gonna be building today. And yeah, also this instruction says, or hit F1. In case you don't know, if you hit F1, it will go to perform mode. So yeah. And just kind of curious what everyone's hardware situation is too. I put this, your current frame rate. I am using a workstation, so I'm on 60. But I'm, just curious what frame rate you are getting. If you could put that if you don't mind putting that in a chat, it's just it helps me to understand what everyone's situation is. And let's see, 30? Yeah, that's good. Yeah, that's good. At least 30 would be good, right? Yeah, if it's chugging say 10 or I don't know, 5, there's things that I can help to make it, easier for you. So yeah. Yeah, with that being said, I think I want to quickly summarize what, we will go through today. Okay, thank you. Yeah, so everyone's getting either 30 to 60. Okay, so that's good. So if we just, let's look at, overview of this network. So it will kind of break down into, I'm thinking sort of 5 steps today. So the first step will be making this part, which, making the structure of the tree itself using L system. And then after that, we will be doing the instancing of the leaves. So which is basically these guys here. And then, along the way, we'll make it interactive with your mouse cursor. So yeah, and then also there's a particles that's, it's a separated part that we will do that next. And then lastly, we will work on this whole rendering part of it and making a water reflections and so on, so on. So yeah, let's start, if you could open a new scene, I'll just bring this one away, and then let me open a blank scene. And yeah, if you are using, like a default file, you can just click and delete all of the nodes that come with it. So first, let's make, you can double click the network and then go to SOP and type in L-system. Okay, so by default, L-system will give you this default tree. And how L-system works is it uses these rules. So you see there's a premise, and then there's A, this is the rule, and then B. So I think a quick, first time, of course, right? So this is quite alien, it's not Python or anything, it's totally alien language. So I think, let's do a quick refresher, or if it's first time for you, it's an intro. It won't be too bad. So this is a little board I prepared. Let's see what we are making first, just in case. So I'm gonna be making this momiji in Japanese. And it's a Japanese maple tree, and it's a really, really beautiful, as you can see, it's like the autumn tree in Japan. It goes red or like orange or yellow. And yeah, I wonder, is it time yet in Japan? It might not be yet. It's usually like around, end of October to like November. Not yet. Okay, yeah, it's not cold enough. Yeah, but in Kyoto or everywhere in Japan, obviously, it's really quite beautiful, like these pictures. And something interesting I found was, I guess this is more like a wild momiji tree. It's like really full. But these are like kind of ones that's like really well pruned, and I got deep into pruning of momiji tree. So kind of like, it naturally it seems like it goes three ways. So it's similar to the L-system default shape, but sounds like, it's like sort of an aesthetic thing in Japan to make it like a 2 and 2. So like bifurcating, So you see, it's all like 2 and 2s. And I think, if you do that, you kind of get a little bit more sort of, this type of, there's some gap to it. It's not just like a full tree like this one. So that's something like I'm going for, like let's make it sort of like, has a little bit of a character. And the way we are gonna tackle today, so this is, I like this illustration. So you see like there's a sort of like a main trunk part. So we'll make the main trunk as a 1L system. And then you see like, from here, there's like a little tree, right? Like with leaves. So there's a lot of little tree on top on this big tree. So this little tree will be another L system that we are gonna make. And the little tree part, I'm thinking, sort of like this, like we're gonna make, something like this, just like starts with 1 and then separate into 2 and then separate into 2. And then maybe keeps going, kind of like this one. So I think this part will be a little bit more simpler. So we'll start from this simpler part to sort of try to understand, this L system. And well, so if you could make it viewer active here, and then we'll just delete these rules. So there is nothing to start. So premise is something that happens at your beginning of the creation. So if you say F, what you get is a line. So F steps forward. So, we made one line. And if you see this L system's parameter here, there is this generations. And we want to bring this generation down to like 2 for now. Okay. So, and then after this F that we just made, well, maybe since, some of you first time, so like, see what happens to F is like, it just keeps going, right? But this doesn't really change with the generation because it only happens at the beginning. So how it works, instead of just keep writing on this premise, we'll start using what is called rules. And for the first rule that we're gonna write is going to be, so we say premise to be FA. And A, at this point, it just doesn't mean anything. It's like a null. And so as a rule, we say A is equal to F. So again, this is probably what, right? But from here, so we just have a straight line. But now we want to, like I told you, we want to separate into like 2 lines. So like we need to make a branch. So to make a branch, we use this squared bracket. And then if you want to go to the right, you use plus sign and then F and then close bracket. And it's important that F is a capital F, okay? So now you see it went 1 to the right. So in the same manner, if you branch out minus F, so that'll make, go to the left side. And then this plus and minus, how much it, rotates, like this angle here, from here, is decided by this parameter page is this angle. So if you change this angle, that's how much it will rotate to the right or the left. So for now, you can just leave it at 28. Yeah, and then from here, so, so this one is the plus and then this one is minus. So at this point, now what I want to do is to add B, which again, it doesn't mean anything until you say what the B is. So let's just add it. Now, second rule, we write B is equal to, and then we're gonna do a very similar thing. So we say, step forward. So we can see it goes step forward, right? And then again, the square bracket, plus F, close, minus F, right? So it split again. But from here, instead of, keep splitting and splitting, from here, I just wanted to go, kind of like this type of reference here. So here's the kind of magic that you can use, which is if you say B at the end, so it will do same thing again. And now make sure your generation is right now 2, but as you increase, it will, keep repeating itself. So this is kind of, I think 3 is fine. And then, so each end of these here, I like that, separated, okay, yeah. Yeah, sorry, it's, it might be going a little fast for first time L-system people, but no worries, because, as soon as we get through this one and the main one, like it's gonna be, that's it. So yeah, don't worry too much. Let's make a little leaf. So for now, we are gonna use a circle. So that will be our placeholder for our leaf. And then leaf, if you hover over this input, there's leaf J input, K, and then M. And then last one is a meta test. So that's something else, okay? And circle goes to, plug your circle into first input. And then nothing happens because we need to tell this J. So we need to put J into our rule. And then where do I want to put the J is going to be, so, it branch out F right here, right? So after this F, which is this part. So if you put J and J, and I like to make it viewer active here and hit W for wireframe. I think make your circle radius smaller. Something like that. Okay, so now we have a leaf on the each ending. And then, yeah, so from here, they are, it's really flat, like from the side. And I think by looking at some of these references, it is kind of facing, towards the sky, but it likes to kind of like, going upwards to the sky. So to do that, I thought this is a good thing to show you now. So F, just makes a line, and the plus F goes to the right. And then this is if the angle was 90 degrees, right? And minus F goes to the left. And in a similar way, there's and this is caret sign. Yeah, and goes to the back, and then caret comes to the forward. So we'll be using this and sign next. So this one that goes to plus fj, right? So we can also say and. So now you see these guys went backwards, so now it's kind of actually three-dimensional thing happening. So do the same thing to this side as well. Right. So this is like, almost what I want. And yeah, from here, I think I want to cover, variables, which is, if you go to the value page, there are this variable BCD. And why I want to use it is because right now, like everything changes with this angle globally. And, sometimes it's nice to like, you might want to have, different angle here and here and so on. So I want to use this variable assigned to how much, these each branches will rotate. So to do that, like we, right after this plus, so put the parentheses. And you could actually like hard code like 30, or maybe it doesn't look too different, just to show you, it's like 60. So this using parentheses, really specify hard code it, like how much you would like. But you can say, use a variable there. So now this variable B will become kind of like your slider, that you can use. And I think in this case, it's fine to be kind of symmetrical. So I want to use same variables here. So yeah, now, this only changing this main portion, and then top portion has a separated control. So that's something fun I think you can do with it. Yeah, and then I think couple more good things to know using L-system is, so this tilde sign, it's for randomizing, because nature is not completely perfect. So it's nice to introduce a little bit of randomization in your rules. And then, like we just saw, like if you use parentheses, you can say how much randomness that you want to add, and this is in degrees. So that's something we can do for this one to make it a little bit, less perfect. So we'll do that. Let's do that onto the main portion first. So put tilde and then do like 10. See what happens. So it kind of like tilted. Once you do that, you can use this random seed on the geometry page. So this is, as soon as you introduce this tilde sign, you can randomize your tree. Okay. And then I think, it's nice to also do it to this top part. So you can just copy and paste that. Yeah, so now, not all of them are exactly the same. So it starts to look a little bit more interesting. And I think another thing that's good to know is this double quotation mark. Let's add it to here as well. So what this one does, you see it's got a little smaller. So this double quotation mark, it multiplies this value. Let's see, the step size scale. So, plants often, the newer part of the plant is a little smaller, right? So that's something you can use. So, since it's multiplying, if it's somewhat getting bigger and bigger as it gets taller, then you can even go over 1. But for here, I think we just need a little bit, just a little touch, like 0.9 is fine. Yeah, so that makes our leaf part, and if you like it, you can, increase more. You don't want to do too much yet because it, once it's on the tree, there will be a lot of leaves. Okay, so did everyone get through this fine? I hope. So next one, just make a brand new L system. Okay, that's good. So yeah, so this one is going to be the main part of the tree. And I think it's good to show you what is in the asset folder. So in the example folder, if you go to asset, there is this ablock.pdf. And I like this page, but so this is a book called Algorithmic Beauty of Plants. And he is the Lindenmayer, and L-system stands for his name. So he invented these rules back in like 1960s. And it's his book. And most of, there's a lot of things in here. And there's no way I can cover all of it in this short time. But again, the last workshop covered a lot of basic part. So if you like this kind of stuff, like it's really good to check it out. So in this book, there's a tree section, and I thought, modeling of trees. It's always easy to go off of something, closer to what you want to do. So for me, I think it's important to kind of study the reference first. And I think, the closest, like I thought it's gonna work good for making maple tree was this type of tree called monopodial tree-like structures of Honda. And yeah. And maybe, it's good to even show how you could go about if you wanted to use these rules. And it sort of doesn't look like same. There's like, what is this and what is that, right? So this part is gonna be your premise. And then that's gonna be your first rule, which like, we kind of did, right? A and B and C. So yeah, you can, kind of think of like that you can even copy and paste that to be premise, and then that will be your A. And this part, you can just replace it with equal sign. So, you know, once you understand that, like, it won't be too hard to implement something you like from the book. And yeah, like, you know, if you read, like this says like R1 should be 0.9. So, you know, you can just replace this with 0.9. But I thought, you know, this is still sort of a lot to deal with and intimidating. Just so, you know, knowing that I'm based on this one, like, but I simplified the rule a little bit. And that's what we are going to try. Yeah. Okay, so with that being said, let's delete everything again. Okay, and then, so the first one, just, you know, always kind of start with F, have a straight line. And then we say FA, again, A was nothing, right? So what do we want to do with A? So again, like if we see our tree, you know, this one quite similar, right? We want to have F and then keep going, right? This is the main trunk, but there's a branch to it. So in a way, it's very similar to what we just did on this one. So we say F and then bracket, and the book uses and instead of plus. You know, it's almost same thing, but it's just going to this like forward or backwards. So we do that, and then you could say F. Let's see what happens. If you rotate, it's there, right? So F, and then it went that way. And then from here, you can say, so this slash is a roll. So it will rotate along this like y-axis. And if you type in 137.5, and 137.5 degree is sort of magic number of these plants. Like they tend to have these degrees when, you know, you study how the plant decides which way to put their leaves. And apparently that makes it really efficient for the plant to distribute, you know. Everyone gets the sun. So that's what it is. So it's like, you know, rotate for 137.5, and then we say A. So what happened is, if you see from the top, so each time it's rotating 137.5, you know, the first one is here and the next one, 137.5. Okay, so that's kind of, you know, basic. And over here, we said F, which is just kind of going this way. But we want to replace that with a new rule. So replace that with B. Okay, so it will go away. And now we want to write what the B's are, which we will start with F. So, you know, back to how it was. And this one, like we also want them to branch out as well. So branching is the square bracket. And then we say minus. And then we do here, now we do C, which is also a new rule that's not, you know, decided yet. And we can say what the C is, right? So here. And C will be sort of like the reverse of the B. It will make sense, I think, once things are in there. So we put the F and then bracket. So instead of minus, this time we go to plus and then C. I'm sorry, B. So you see it's kind of making this zigzag motion, right? because it's going left and then back to C and B and C. And we also need them to, right now, they are just kind of like, one lines, but we need them to also branch out. So at the end of each ones, we tell them to repeat itself, like kind of in backwards manner. So B will repeat C, and then C will repeat B. So by doing this, it will, so this one went to the left, right? And the branching is on going to the right. So it's like kind of like going left and right. So yeah, it's definitely a little confusing probably because it's, making a fractal by this code that like loops. But that's okay, it is a little bit confusing. But yeah, so from here, the book also introduces dollar mark sign, which, let's see, there it is. Yeah, this mathematical thing is definitely, beyond my expertise to, sort of being able to tell you what they are. But yeah, there's this like symbol, dollar mark sign that's being used here. And usually like this dollar mark sign is, what it does, it's like point towards the sun. So unless you specify where the sun is, it will be up in Y. So it is introducing this dollar mark sign into like right before these C and B. How have we defined B or C? Okay, so there's a good question. Okay, well, I think I would like to answer that question first. So how have we defined B or C? So B is defined right here, right? So B is equal to, and C is equal to. So this is basically where it's defining what the B is. And before C is written, C means nothing, but now C is this one. So it is sort of, creating these loops, and that's what makes it keeps growing and growing, if that makes sense. Anyhow, so yeah, this dollar mark sign, what it did, it was like before this one was also like perfect plane. I can show you, don't have to do this, but I can show you by taking out. So this was like totally flat, from here. But by adding this one, it will add like extra, rotation at this section that it will, distribute a little bit nicely. And I think, that's the best I can explain. So I don't want to get too deep into that. But yeah, so this kind of makes already, really good structure for the Japanese maple tree that it always, splitting into two. That's the shape that, I'm going for, a little bit more pruned Japanese maple tree. Yeah, and then I think from here, I think I want to, this is really the main structure. And from here, it's like a sort of, adding a little bit more character to it to make it a little bit more natural. And some of these important, things that I wanted you to, take away is that T is for gravity. And in botany, it's called tropism. So it stands for the tropism, but I remember it's gravity. And the randomness we just did, right? So let's add some gravity because it's very fun. So adding gravity is really, really easy. You can just add a T at the beginning of your code. And I think the main trunk is just kind of going upwards. So we can do it for add gravity to these, branches, because they look, they're gonna be heavy and they will kind of go down, right? So if you add T at the beginning and go to your L systems values gravity and here. So now, you can go upwards too. Now this reacts to your, value, gravity value. And I think I like to keep it something like 5. And we can also add gravity to the C, because they are like, sort of brothers and sisters. So they do that similar thing, just opposite way. All right. So I think this is pretty good. I also wanted to use the variables again for, first it goes this side, which was this one. So we can add a variable here. And we can call it, the first one is B, so we can use B. And that's this one. So let's put like maybe 45. And so now, like, these guys could also have that too. So after the minus, if we put C, we can specify, how much it turns left and how much it turns right using this C. And I think in the book, it was using negative value. So yeah, this will make kind of similar to what the book's example is doing. And yeah, I think from here, we can, kind of like what we did with this one, we could also add a little bit of randomization. So that's a tilde sign. We can do tilde parentheses like 5. And same thing. So now we can check random seed will make it random, right? Yeah, it started to look, groovy. Yeah, and I think, it becomes almost always the same thing that you can add. You will sort of get used to it if you stick to it. And we also want to do this double quotation mark for the length, so that, length gets like a little shorter and shorter as it goes. So we can add that length onto, right after the T, we can add the double quotation mark, right? And again, that corresponds to this step size scale. So not too much. Yeah. All right. So I think this is pretty, in a good place where we are to maybe save your project. I'll do that too. We want to now put these leaves, actually put on this big tree. So for doing this, it might be helpful to see a little bit of color. So I will put a little distance there. Let's put points up. And you can say add color. Let's put orange. And yeah, it's there. So this one, we did use leaf J input. And later on, we want to keep this J input as a separated group. So this time, we will use K input. So plug this into K. Okay. And then we'll add K into here. Now I will make view active and hit W. And so they are small, but it's there. Speaking of the scale, so this tree seems quite small right now. It's like less than 1. And controlling the scale of L system, you go to this value tab, and this step size really, changes the size of the tree. So let's make our main, main tree to be 1, because it should be, big. Yeah, so I think that's good, like, a little less than 10. And now this one, this little tree or little leaf, and there, I'm looking at this one, there step size can be maybe a little bigger, like for now, maybe 0.2 or 0.3. I think 0.3. Yeah, 0.3 seems fine. Okay. So now what we have is, it's all this sort of, it's a skeleton trees, right? And there's a option that you can change. If you go to this geometry tab, you can change skeleton to tube. And what that does is it will make it, actually cylinder, but they are very skinny right now. And to change the thickness, now, as soon as you change this to tube, if you go to tube, there's this thickness that you can change. So first of all, like, let's make it thicker. And we have a major problem, which is the top of the tree is just all same width. And to fix that, we can use exclamation mark. So this is new rules that we haven't done yet. So you can add exclamation mark to all of them. So what this does is this one, this thickness scale, it will multiply as it grows in the generation, like so. And I think the book says that something like 0.707 is like, apparently Leonardo da Vinci figured that that's the number. So I'll borrow that. But yeah, I think it looks pretty good, right? I mean, it's little, okay, so it's this twist, twist is little struggling there. As well, I think for rendering today, we want to make it look nice. So, the triangle, it's 3 divisions is probably not enough. So you can raise these rows to like 6 at least. So that should make it, more rounded and nice. Okay, so we can do the same thing to this one as well. So turn on tube and add that exclamation mark. And then make it a little thicker. And then thickness scale, like 0.7 or, you can eyeball it. I might make it a little smaller. Let's check. All right. Yeah, I think this top portion, I don't really want to make it too high resolution. So I just keep it as 3 divisions in the rows. There's a question. Da Vinci Code. Can we export tree to other platform like a SketchUp? That's a good question. Let's see. So in TouchDesigner, what you could do is like you can right click and save geometry. But, oh, there is FBX. BH Classic could be good for exporting like Houdini if you ever will, you know, BH Classic is good for that. You can do FBX, and most of the software will accept FBX. So you can, you know, just write that to. So, but okay, FBX supports only polygons and norms. So it's, there's a problem with it. I wonder if it's because of this, that's polygon. That's an interesting question. I think we need to make sure that it is polygon, but there are meshes. So it might be upset about these meshes. I'm interested to, you know, maybe take a look during the break time. Yeah. Could you click on your point node? Okay, my point node doesn't have an add color. This one. I only have keep color. Really? Did you click this part? Ah, there you go. Yeah. So you can choose, you know, you can choose this label, and then you can put a color. Yeah. This, you know, later I will delete this actually. It's just, I just wanted to see it quickly, but yeah. Well, okay, so back to, you know, this tubing process. It is important later on that it has this tube texture coordinates on. So we do the same thing for both of them. Okay. So yeah, this will help us to actually put, you know, bark texture to the tree. So we'll need that going. And okay. So this one should be plugged into the K, and make sure you added K in the code. I lost my chat box here. Having still the same problem. The color might be gone though. The orange color might be gone, but this should be there. Make sure your circle is big enough. It could be, I don't know, maybe too small. Okay, yeah, that's right. Yeah, that's okay. All right, so yeah, go take a break.